Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at completing the square. So completing the square is when you take a quadratic expression like this and you write it in the form x plus or minus something squared plus or minus something. It turns out that this form is beneficial when it comes to graphing parabolas, but I'll also show you an example later where this method is very helpful when you have to factorize expressions with large numbers. So for now, let's just put this expression in this form. So which number goes in each box? Well, it turns out I'm going to put a 5 in this box. Why did I pick 5 of all numbers? Well, it turns out 5 goes there because it is half of b. It's half of the coefficient of x. So why is it that this number has to be half of this one? Well, let's look at what happens when you expand x plus 5 squared. Using this rule up here, x plus 5 squared gives you x squared plus 10x plus 25. So that's what would happen if you were to expand this. Notice, when you expand a perfect binomial square, this number is always double that number. Okay, so where are we? Well, we have x squared plus 10x plus 20. If I expand this, I get x squared plus 10x plus 25, not plus 20. So what I need to do is I need to adjust for this. 20 is 25 minus 5. See, now that I've subtracted the 5, this expression and this expression are exactly the same. So because this is x plus 5 squared, we have reduced this to x plus 5 squared minus 5. We have completed the square. We've put this in completing the square form because this expression and this expression are exactly the same. So this can help us solve the equation. How do I now solve this? I need to factorize again using difference of two squares. This is how you use difference of two squares. You get two brackets, you square root the first thing, so the square root of this one here is x plus 5. Then you square root the second thing, so square root of 5, I'll just leave like that. One bracket gets a plus, one bracket gets a minus. So now I factorized it as something times something equals 0. Either the first something equals 0, which would mean x is negative 5 minus root 5, or the second bracket equals 0. In that case, x would be minus 5 plus root 5. We usually just write it like this for convenience. Minus 5 plus or minus square root of 5. These are the two solutions to this equation, and we got that through completing the square. Let's now look at some other examples. So this is the example to which I was referring earlier. So the normal method of factorizing monic quadratic trinomials, we need to find two numbers that multiply to this and add to this. The problem is that this is a very large number, could be a number with lots of factors as well, so that may take a long time. So to get around that, we can use completing the square. So to do completing the square, we want to write it as x plus or minus something squared. So we're going to write it as x minus 26 squared. Why did I choose negative 26 of all numbers? It's half this coefficient. This coefficient is negative 52. Half of it goes inside the brackets. But see, the problem is when I expand x minus 26 squared, I would get x squared minus 52x plus 26 squared, which is 676. I don't want 676, I want 555. So to go from 676 to 555, I actually need to subtract 121. So now they're balanced. This expression in blue and the expression in black are exactly the same. If you expand this and subtract 121, you will get that. So that helps us. Now I can use difference of two squares to factorize further. So difference of two squares, you square root the first thing and then you square root the second thing. So square root of 121 is 11. One bracket gets a plus, one gets a minus. So of course, negative 26 plus 11 is negative 15. So it's going to be x minus 15. The other bracket is x minus 37. Now we have something times something equals 0. Either the first bracket equals 0, which means x is 15, or the second bracket equals 0, meaning x is 37. It turns out 37 and 15 multiply to 555, but to come up with those factors would have been very challenging, so completing the square helped us. Let's complete the square for this expression here. So we're going to halve this, so it'll become x plus 4 all squared. But if you expand this, you get x squared plus 8x. On the end would be 4 squared. 4 squared is 16, not 17. So what I need to do so that these two are the same is I need to add 1. 17 is 16 plus 1. Now it turns out we have a perfect square and a perfect square, but they're added. This is the sum of squares, not the difference of squares. So when this happens, there is actually no solution. To see that, if we were to subtract 1 from both sides, so get rid of this 1 by subtracting it, we would get a perfect square, x plus 4 squared equals negative 1. You cannot have a perfect square equaling negative 1. So when this number outside the brackets is negative, there will be 1 or 2 solutions. But when this number outside the bracket is positive, there are no solutions. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.